Hi guys, this is Mrs. Henry and we are working on solving exponential equations today. This is section 7.2. Let me know if you have questions after the video. Now we're going to do some problems and show you some examples. So when we have equations with the same base, if they're equal, our exponents must also equal. So x plus 1 equals 9. Subtract 1 from both sides. X equals 8. When we plug this back in, 8 plus 1 is 9. These are equal, and this is my solution. Our next example is I have we have to first combine my exponents. When I multiply, I keep the base the same and I add the exponents. So k plus 2 is 2k plus 2 equals 3 to the 5k minus 1. When my bases are the same, my exponents have to equal each other. So 2k plus 2 equals 5k minus 1. Subtract 2k from both sides. This becomes 0. 2 equals 3k minus 1. Add 1 to both sides. 3 equals 3k. So k equals 1. Let's see if this works. 1 plus 1 plus 2 is 4. 5 times 1 is 5, minus 1 is 4. This works. Fantastic. If it doesn't work, then it's called an extraneous root. So now we've done a couple basic ones. Let's look at what happens when my bases are not the same. So I get something that looks like this. 6 to the 2k minus 10 equals 36. 6 and 36 are not equal. But can I make 36 have a base of 6? Yes, I can. So this becomes now they have the same bases. And when the bases are the same, the exponents have to equal each other. Then I solve my equation. Add 10 to both sides. And I have 2k equals 12. Divide both sides by 2. K equals 6. When I plug this in, 2 times 6 is 12, minus 10 is 2, which is right here. So this equals. Let's try another. How do I make 1/7 have a base of 7? Remember when I use negative exponents, it creates fractions. So my exponent is -1. So now we solve our equation. I get 4x plus 11 equals -1. Subtract 11 from both sides. 4x equals -12. Divide by 4. X equals -3. 4 times -3 is -12, plus 11 is -1, which is equal to here. This is my solution. My next example becomes 27 to the 2x plus 6 equals 3 to the 2x. Now, can I make 27 have a base of 3? Yes, it's 3 cubed. Why did I put this in parentheses? Because when I multiply, well, when I raise a power to a power, I keep the bases the same and I multiply the exponents. That's why we're going to have to distribute there. So I have 3 times 2x plus 6 equals 2x. I have 6x plus 18 equals 2x. Divide by 6x, or I'm sorry, subtract by 6x. That becomes 0. 18 equals -4x. Divide by -4. X equals -4.5. And that's how we solve that one. Now, let me do a few more, and then we'll be done with the video and we'll move on to our next video. I get 125x equals 25. We have to come up with the same base. And our base here is going to be 5 for both. So 125 is 5 to the 3rd power. Remember, we need to keep the x in there. And 25 is 5 squared. So 3x equals 2. Divide both sides by 3. And x equals 2/3. I have 1, 2, 3, 4 more examples I want to do with you. And then we'll be done this video. Here, can I make 4 and 8 have the same base? My base here is going to be 2. 2 to the 2 times 3x equals 2 to the 3 times x minus 1. So now we're going to rewrite my equation so I can solve for x. So I get 6x equals 3x minus 3. Subtract 3x from both sides. 3x equals -3. Divide by 3. X equals -1. So, -3 times 2 is 6. -2 times 3 is -6, and we're good. Now, I have 8 to the 2a minus 1 equals 32 to the 2a plus 1. So now I have to make them both have bases of 2. So 2 to the what power is 8? 2 to the 3rd power. And 2 to the what power is 32? 2 to the 5th. So I'm going to rewrite my equation minus 3 equals 10a plus 5. Subtract 6a from both sides. So I get negative 3 equals 4a plus 5. Subtract 5 from both sides. Negative 8 equals 4a. Divide by 4. A equals negative 2. I know this is less than ideal because I'm actually teaching on my couch and not on a normal board, and I'm kind of hunched over. Hopefully this is working for everybody. I'm doing my best to help you all out.
Try to center the writing on the board away from you.
Okay, apparently I'm getting close to the edge over here. I just thought it was easier for me. 64 equals 4 times 4 to the 4x. We're going to make all of these have a base of 4. So 64 is 4 to the third power, and 4 is 4 to the first power. So when I multiply, I keep the bases the same, and I add these exponents. So I have 3 equals 1 plus 4x. Subtract 1, and I get 2 equals 4x. Divide by 4, x equals 1/2. My last example is this. So all of these need to have a base of 7. This becomes 7 to the negative 1. This becomes 7 to the squared times x minus 5 times 7 to the x minus 9. Remember, when we multiply, we keep the bases the same, and we're going to add these two. So I get negative 1 equals 2 times x minus 5 plus x minus 9. So I have negative 1 equals 2x minus 10 plus x minus 9. We're going to combine like terms. I get negative 1 equals 3x minus 19. Add 19 to both sides. 18 equals 3x. Divide by 3. And x equals 6. And that's how we solve exponential equations, creating common bases. Let me know if you need any help. Good luck. Bye, guys.